Greetings, fellow Earthlings! Welcome to the new adventure of the Earth Scientific Journey. I am Teacher Delves, your Earth Science enthusiast. Today, we will explore another mystery of science, the fascinating world of stratigraphy and relative dating. So, buckle up, dear explorer, as we get forth to unravel the mysteries that surround us on this extraordinary scientific adventure. After going through to this lesson, you are expected to do the following. Describe how layers of rocks are formed. Identify the different laws of stratigraphy. Learn how the relative position of rocks reveal about its history. Before we proceed with our lesson, answer the following questions. Question number 1. Which type of rock is formed when bits of rocks are layered and cemented together? A. Deposition. B. Igneous rocks. C. Sedimentary rock. D. Metamorphic rock. What is your answer? Very good. The correct answer is sedimentary rock. Question number 2. If you encountered a sequence of rocks that are now tilted or folded, what does it suggest? A. The rocks were originally horizontal, but the Earth's rotation caused them to tilt. B. The rocks were initially folded during their formation. C. Some tectonic or geological forces have acted upon them after their initial deposition. Or letter D. The rocks have been eroded over time, causing their tilting. What do you think is the best answer? You got it right. It's letter C. Some tectonic or geological forces have acted upon them after their initial deposition. Question number 3. In a coastal town, you find layers of sand, clay, and shells compacted together. What is the most likely process responsible for the formation of these sedimentary layers? A. Igneous intrusion. B. Volcanic eruption. C. Erosion and deposition. Or letter D. Plate tectonics. What do you think is the correct answer? Very good. It's letter D. Plate tectonics. Question number 4. In a rock sequence, you discovered an igneous intrusion that cuts across several sedimentary layers. What can you infer about the age of the igneous intrusion? A. It is older than the sedimentary layers. B. It is approximately the same age as the sedimentary layers. C. It is unrelated to the age of the sedimentary layers. Or letter D. It is younger than the sedimentary layers. What do you think is the correct answer? Very good. It's letter D. It is younger than the sedimentary layers. Question number 5. At the dig site, you find a layer of conglomerate rock containing well-rounded pebbles resting on top of a layer of shale. What can you conclude about the deposition of these layers? A. The conglomerate layer is older than the shale layer. B. The shale layer is older than the conglomerate layer. C. Both layers form simultaneously. Or letter D. The relative ages cannot be determined from the information. What do you think is the correct answer? Do you think you get this right this time? Yes, it's letter B. The shale layer is older than the conglomerate layer.
Imagine you're reading a book, but instead of pages, you're flipping through the layers of rocks. It is like a detective game where scientists figure out what happened in the past by looking at these rock layers, using rocks as its language and fossils as its illustrations. So let's open up this geological book and start reading the amazing story of our planet's history. Our story begins with James Hutton, who introduced the concept of uniformitarianism. This principle tells us that the same natural processes we see around us today have been operating on Earth for millions of years. In simpler terms, the present is the key to the past. This idea revolutionized our understanding of Earth's history and time itself. But how do we uncover this ancient history? Well, before we could accurately determine the ages of materials, early geologists relied on keen observation to decipher the sequence of events. Building upon the ideas of Nicholas Steno, the father of stratigraphy, who proposed how rocks are arranged, they laid the foundation for a field known as stratigraphy. But what is stratigraphy? Stratigraphy is the study of rock layers, and it's like reading a book written by the earth itself. You see, rocks that form in layers are called stratified rocks. These layers, much like the pages of a history book, contain essential information about Earth's past. To understand the language of stratigraphy, we need to master its fundamental principles. These principles act as our compass in deciphering the Earth's geological story. So are you ready? Let's dive into them one by one. Imagine you are walking in this library. Each shelf represents a different time period in history, and the books on those shelves are like the rock layers in Earth. Just like books are arranged on shelves, rocks are arranged in layers on the Earth's surface. As you wander through the library, you notice that the newest books are always placed on the top of the shelf, while the older books are on the lower shelves. This is similar to the law of superposition in stratigraphy. In rock layers, the youngest rocks are usually on top, and the older rocks are found below. It states that in a sequence of undisturbed sedimentary rocks, the youngest rocks are on top, and the oldest rocks are at the bottom. In other words, as sedimentary layers accumulate over time, the newer layers are deposited on top of older ones. Upon looking the shelves, you see that all the books are standing upright on the shelves. This is similar to the law of original horizontality. When rocks are first formed, they're often laid down in horizontal layers. This principle states that sediments are originally deposited in horizontal layers. If you find a sequence of rocks that are now tilted or folded, it suggests that some tectonic or geological forces have acted upon them after their initial deposition. But then, something caught your eyes on one shelf. The book seems to extend beyond the edge of the shelf and continue onto the adjacent shelf. This was similar to the law of lateral continuity in geology. Rock layers were originally continuous over large areas but may have been eroded or interrupted by geological processes. This law states that layers of sediment initially extend in all directions until they thin out or encounter a barrier. This principle allows geologists to correlate and match up rock layers that are separated by erosion, faulting, or other geological processes. Further into the library, you discovered a special bookmark sticking out from the pages of an old book. It was a bookmark from another time. Just like the law of cross-cutting relationships reveals that if one layer of rock cuts across another, it must be younger. It was as though time had left its own markers in the Earth's story. This principle states that any feature that cuts across rock layers must be younger than the rocks it cuts through. For example, a fault or an igneous intrusion that cuts across sedimentary layers is younger than those layers. Finally, you come across a section where several shelves seem to be missing books, leaving gaps in the otherwise continuous arrangement. This is similar to the law of unconformities in stratigraphy. Unconformities in geology represent gaps or missing portions in the rock record due to erosion or non-deposition. Just as some shelves in the library have missing books, unconformities indicate periods where rock layers were eroded away or not deposited, leaving an interruption in geological history. An angular unconformity occurs when older, tilted, or folded sedimentary rocks are overlain by younger, horizontally sedimentary rocks. The older rocks have been subjected to deformation, such as folding or tilting, before the deposition of the younger rocks. This type of unconformity represents a period of erosion and tectonic activity between the deposition of the older and younger sedimentary layers. A disconformity is an unconformity where there is a gap in the sedimentary rock layers or sequence, but the layers above and below the gap are parallel to each other. In other words, the sedimentary rocks on either side of the disconformity are horizontal and have not been significantly deformed. Disconformities typically represents period of erosion or non-deposition, but without the tilting or folding seen in angular unconformities. A nonconformity occurs when sedimentary rocks overlay crystalline or igneous rocks without any sedimentary rocks in between. This type of unconformity represents a significant gap in geological record, indicating that the period of erosion or non-deposition followed the formation and exposure of the crystalline or igneous rocks before the deposition of the overlying sedimentary rocks.
Do you know that one of the oldest rocks in the Philippines was formed at the same time the dinosaurs were roaming our planet? This is the Jurassic sandstone, a dark gray, indurated, fine-grained sandstones collected in Cabalua, Mansalay in the province of Oriental Mindoro. Based on the fossil content, this rock is dated to be late Middle Jurassic to early Late Jurassic age. That is why it is called the Jurassic Sandstone. Knowing about this provides us with the unique opportunity to appreciate the deep geological history of our country and our planet. If you want to see this ancient specimen along with the other interesting collections, be sure to give a visit to the National Museum of the Philippines.
We have just covered some important information in today's lesson. Now, it's time to assess your understanding of the topic by answering the comprehension questions.
Question number 1. In a rocky outcrop, you notice that a fault cuts through several layers of rock, displacing them horizontally. What does this suggest about the relative timing of the fault and the rock layers? A. The rock formed after the rock layers were deposited. B. The fault formed before the rock layers were deposited. C. The fault formed at the same time as the rock layers. Or letter D, there's not enough information to make an inference. What is your answer from this question? Very good, it's letter A. The fault formed after the rock layers were deposited. Question number 2. You find a layer of volcanic ash sandwiched between two layers of sedimentary rock. What can you deduce about the sequence of events? A. The volcanic ash layer was deposited first, followed by the sedimentary rocks. B. The sedimentary rocks were deposited first, followed by the volcanic ash layer. C. The volcanic ash and sedimentary rocks were deposited simultaneously. Or letter D. It's impossible to determine the sequence of events from this information. Now, what is your answer? That is correct. It's letter B. The sedimentary rocks were deposited first, followed by the volcanic ash layer. Question number 3. While exploring a canyon, you observe an igneous intrusion that cuts through the surrounding sedimentary rock layers. What can you conclude about the relative timing of these events? A. The sedimentary rock layers formed after the igneous intrusion. B. The igneous intrusion occurred after the sedimentary rock layers. C. The igneous intrusion had no impact on the sedimentary rock layers. Or letter D. The igneous intrusion and sedimentary rock layers formed simultaneously. What do you think is the best answer? Very good, it's letter B. The igneous intrusion occurred after the sedimentary rock layers. Question number 4. You are hiking along a river bank and you come across layers of rocks that appear to be sedimentary. What is the most likely process that formed these rocks? A. Igneous activity. B. Tectonic plate movement. C. Weathering and erosion. Or letter D. Volcanic eruption. Okay, what is your answer? Very good, it's letter C. Weathering and erosion. Question number 5. What are the laws of stratigraphy primarily used for? A. Determining the chemical composition of rocks. B. Establishing the absolute ages of rock layers. C. Interpreting the relative ages of rock layers. Or letter D. Studying the seismic activity of an area. Okay, so what is your answer from this question? That is right, it's letter C. Interpreting the relative ages of rock layers.
Thank you for participating in our scientific adventure. Join us again for another exciting exploration. I am Teacher Delves, your Earth Science enthusiast, saying, Earth Science is a journey of discovery that never ends. See you and goodbye!